On to the second problem, which is the tiger and sheep problem. So there are 100 tigers and one sheep put on a magical island that has only grass. Tiger can eat grass, but they would rather eat sheep, obviously. Assume A, each time only one tiger can eat one sheep, okay? And if that tiger eats itself, it becomes a sheep. After it eats the sheep, B, all tigers are smart, perfectly rational, they would want to survive. So will the sheep be eaten? Again, if we start with 100 sheeps, right? We have 100 tigers. My bad. 100 tigers, one, not 100 sheep. 100 tigers, one sheep. And if we arrange the tigers in such a way that we have these 100 tigers and one sheep, there is no real way to know, or there's no way to logically analyze this problem. Obviously, we can make multiple hypotheses on this could happen, that could happen, but we're not really reaching the end point. So let us instead of going for a top down approach, let's go for a bottom up approach, in which, let's say, there's an island, there's one sheep and one tiger. What would happen in this case? So this is a no brainer, right? This tiger would obviously eat the sheep because there are no repercussions to it. So if the tiger is going to eat the sheep, and in the end you'll have, so the tiger also gets converted to a sheep in the end, so you have one sheep left. There isn't any point in the question where it's mentioned that a tiger would rather prefer being a tiger over a sheep, right? It isn't mentioned anywhere. So in this case, the tiger will eat the sheep and there will be no tiger left on the island, but there will be one sheep. So this is the case with one tiger. Let's say there are two tigers, tiger number one and tiger number two, and there's one sheep, right? And I'm just going to put a T here also, and it's going to be one sheep. So what's going to happen in this case? Will any of these tigers eat? So just to keep it simple, let's start with the highest tiger. Let's assume that's the first tiger that gets to eat the sheep. So what's going to happen in this case? If this tiger eats the sheep, we're going to be left with one tiger, and then this converts to a sheep, right? So we're going to have this case, one tiger, one sheep, and then this case all over again, right? Since it's this case all over again, we know that for sure that the first tiger that became the sheep is also going to get eaten, and this, in the end, you're going to have zero tiger and one sheep. So the second tiger, if it goes to eat the sheep, it's also going to get eaten, right, in the next very step. So in this case, the second tiger probably will not try to eat the sheep because it knows it's also going to get eaten, and it wants to avoid that situation. So let's say in the first case, yes, eat. In the second case, don't eat. So nobody's going to get eaten, right? But let's look at the third case. Let's say there are three tigers, tiger one, tiger two, tiger three, and there's one sheep, right? In this case, what's going to happen? Well, let's say if tiger 3 eats tiger 2, so we're going to be left with one tiger, tiger 1, tiger 2, and then there's going to be one sheep. And this, if you know, is the second case again. This is this case in which there's a don't eat, because, again, going by the assuming all tigers are rational, second tiger is not going to eat the sheep because it knows it's going to get eaten. But the third tiger will eat the sheep because it knows it's not going to get eaten by the second sheep, by the second tiger, because second tiger is not going to eat because it wants to avoid case 1. So in this case, tiger 3 can eat the sheep because when there are two tigers left, nobody's going to touch the sheep. Does that make sense? I hope it does, because this is how it's going to be. So if this additional tiger simply can eat the sheep because it knows in this case no tiger is going to eat the sheep, right? But what if there are 4 tigers, tiger 1, tiger 2, tiger 3, tiger 4, and one sheep? In this case, let's say the fourth tiger eats the sheep, so you're going to be left with tiger 1, tiger 2, tiger 3, and one sheep. And this is this case all over again, in which the sheep is going to get eaten. So to avoid that, the fourth tiger won't try to eat the sheep, don't eat. And if you go and extend this problem, I think you would have seen the pattern now. There are odd number of tigers, then we have a neat condition, which means one sheep is at least eaten. Even number of tigers, you'll see a don't eat flag there, if you can call it a flag. So when you have 100 tigers and one sheep, no tiger is going to eat the sheep. And that's the answer. You're going to be left with 100 tigers and one sheep. If you have any doubts, please post it on the comments and we can have a healthy discussion there. Thank you.